Access Management, or in short called as IAM. So it is a very popular service in AWS. So we'll see that what kind of features we can get from AWS IAM. So during my lecture, if you want to stop me at any point of time, please feel free to stop me, or you can write in the chat box. I can answer to your question before moving to the next topic. So this 2 hour session, we are going to see these topics, starting from the motivation of going for cloud security or cloud computing. Then we'll see the introduction to cloud. What are the different classes of the cloud, and on what basis these classes are categorized, that we'll discuss. Then we'll see the architecture behind cloud computing, although there is no standardized architecture, but many researchers, many forum has given different type of architecture. Based upon the architecture, there are different security policies are enforced. So first we'll visit a very basic architecture and very famous architecture, which is called as market oriented cloud architecture. Then we'll see the success story behind the cloud, because many small to medium scale enterprises are benefited from the cloud. So we'll see some of the live examples from which those enterprises are benefited because of the cloud computing. So although there are several advantages you can see here, but every technology suffers from various type of issues and challenges. And the most time, especially when you talk about cloud or in a overally as a distributed system, people criticize on the security policies, privacy policies. So I'll highlight about why this issue occurred, why people are looking for the cloud security based solutions, and many security protocols are already developed in the field of cryptography and network security, or in normal network security. Why such security protocols are not directly used in the case of cloud? Then we'll specifically focus on four different aspects. One is security, another is privacy, another is trust, another is reputation, followed by the identity access management. So these are the topics that you can expect from this particular session. Now, why we move to the cloud rather than our own premises resources? If you take an example of a organization, maybe a banking organization, or you can talk about our institute. So in which, if I assume that a faculty member is working, let's say 7 hours with a system, it is a rough calculation. It is a 7 hours per day. The person is directly using the computer system. Rest of the time, the computer system is idle. And if I assume that there are 6 working days in a week, so I can say the computer is used by that person for 42 hours. But we know there are 168 hours in a particular week. So irrespective of the utilization, if I see how much time I am going to utilize the computer system, it is nothing but 42 divided by 168, which is 0.25. That means 25% of the time we are using our resources. The rest of the time our computer system is idle. But we are paying for 24 into 7. But we are using the services for 7 cross 6. So this gives a motivation that how to improve the utilization of the resources. In place of one user, if another user is utilizing 25%, so as a whole, I can say the utilization is increased to 50%. If 3 users uses the same system and 25% again by the third person, then I can say utilization is increased to 75%. That's why there are various computing paradigms are available. Not only the cloud. Cloud is not the first one, and in fact, it is not the last one. So every paradigms trying to improve the utilization of the computing resources. Similarly, if you see the IBM case study, old case study and new case study also, you will see the case study mentioned that the utilization of the personal computers that are available across in our world, so it is only utilizing for 5 to 10%. Like if you take a scenario of post COVID situation, or you talk about previous to the COVID situations, so people are engaged in offline classes, so most of the time we are not using our computer system, right? So utilization of the computer systems are very low in various as reported by various case study. Similarly, servers are more powerful than a personal computer. Servers are giving resources to many personal computers. If you go for a particular architecture like client server architecture, so server utilization is also reaching 30 to 35%, not beyond that one. Now, as you can see, 25% I am using the resources of a particular computer system as a faculty member, 5 to 10% for the personal computers, and 30 to 35% for the servers. So it shows a motivation that how to improve the utilization of these computer systems. How to improve the utilization? So in order to improve this utilization, various technologies came into picture. Cloud is one of the technology which improve the utilization without expanding the infrastructure. Not only expanding the infrastructure is the solution, because early days when you are occupied with one particular system, then we go for expanding that particular system, right? So expansion is one of the solution, but managing the infrastructure with existing resources is very much important, because in that it is a cost effective solution compared to the expansion. And if you take this informal example, like if I talk about a newspaper delivery boy, and if I take a Hyderabad city, which is a you can say density based city. So Hyderabad city has a density of 18,161 per kilometer square. So if I subscribe, if I'm staying in Hyderabad, and if I subscribe to a newspaper, so I'll always try that newspaper should reach to me at early morning, let's say before 9 a.m., so that I can go through some of the news before leaving to my office. But I am not going to consider that what is the population of my area. I am not going to consider whether the traffic is normal, or the traffic is very high, or whether it is a public holiday, or it is a working day, or is there any cyclone, or is there any flood. I don't care. I simply need the newspaper every day before 9 a.m. To go through the newspaper, right? So this example shows that if a service is going to be provided to the user is going to use that particular service for which the user is going to pay for it. If the service is not delivered, like in a particular month, if newspaper is delivered for 20 days, I am going to pay for only 20 days. I am not going to pay for the 30 days. So in the similar case, if you go for a site called as Kamsum, whenever we are traveling by train, so Kamsum provides us food. So you can go to the Kamsum site, you can select a station, you can give your basic details including your PNR. It will extract all details from the PNR. And whenever your train reaches to that particular station which you have selected, it is going to provide you the food. And if the food is not provided, you will get a refund. So these example says that if service is given to the user, then only the user is going to pay for that particular service. If service is not provided, I am not going to use for it. Now, if you generalize this into a personal computer and server, so if I am using a personal computer system for 25% of the time, then why should I pay for 100% of the utilization or 100% of the time? Similarly, if a server is used for 30 to 35%, then why should I pay for 100%? If the service is up to 30 to 35%, I am going to provide for 30 to 35%. The reason is that this is considered as our in-house infrastructure. We are maintaining that particular infrastructure, whether it is a personal computer or a workstation, or you can say a computer lab. But when we move to the cloud, what we have, we can get these resources as and when required. So we are going to be charged for that particular resources based upon our usage. Now, this concept is not new. Like if you take in the Google services, very frequently we are using Gmail, Google email system, or we are using Google Map or Google Photos and Google Drive. But if I ask you where the server is located, we do not know where the server is located. Whether it is owning by Google or any third party is involved for maintaining this particular server, that also we don't know. Where is the storage? How many applications are hosted? In which location it is hosted? Whether there is a disaster recovery system or not, we don't have any idea. Just we believe that wherever it may be, it will be in a safer way, right? Or it will be there in a permanent storage kind of thing, so it will never be deleted. And we want to access such type of services using the internet, right? I just want the internet connection and a web browser to open the email system. I've given with a username and password through which I can view my email, irrespective of thinking about where it is located, who is maintaining them, whether there is a proper infrastructure is maintained or not, that we don't care. So this also shows a service-based architecture. If service is provided, then I am happy. If service is not provided, I am not going to pay for that particular services. And some services are free of cost for a short period of time, and some services are charged over a period of time. So, if you see, one of the chief scientists of ARPANET in 1969, his name is Professor Leonard Kleninkroff. He mentioned that after 50 years down the line, okay, from 1969, so if you see, it is coming around 2019, computer will also look like an utility. What do you mean by utility? Like if I talk about electricity, electricity is an utility, and telephone is also treated as an utility. Similarly, computer is also considered as an utility. Like if I am using the electricity for a summer season, if I compare the electricity of a summer season and a winter season, in summer season I am using more electricity because other appliances are there like air conditions and these are on, so I am paying more. And when you go for the winter season, then it is less. So based upon my usage, I am going to pay for my electricity. Similarly, if you look into early days telephone, if I am having more units, then I have to pay more. So there are some free units. If I exceed that, then I have to pay more. If it is within the limit, I am paying some base charge. Similarly, Professor Leonard Klenikerov mentioned that computer will also look like an utility over 50 years of time. Like you can see in 2019, now many startup companies are there. They hosted everything into the cloud without purchasing any server, without purchasing any workstation or a personal computer system. Then, when cloud came into picture in 2007, after that, Professor Rajkumar Bhuya, he mentioned that computing is considered as a fifth utility system after water, electricity, gas, and telephone. Nowadays, water is also based upon what is your consumption in many metro cities. Gas are also coming in pipe, so that is also based upon your usage. So all these are treated as an utility. So computing is also treated as one of the utility. So when we look into the cloud, cloud is nothing but a pool of virtualized computer resources. Like if you take an informal example of a swimming pool has a plenty of water. And if I take a glass of water from the swimming pool, then the water level is not drastically decreased or water level is not drastically increased if I put a glass of water. Similarly, in the case of cloud, it is having a virtualized computer resources from the user perspective. You can look into the cloud in user perspective or you can look into the cloud in the provider perspective. So when we look into the provider perspective, it is not virtualized, it is the actual one. Like if I talk about Google or you talk about Amazon or Microsoft, they maintain these computer resources. For them, it is a physical resources. So why we say it is a virtualized resources? The reason is that as a user, I am using the resources and these resources are not available physically. That is the reason why we say it is a virtualized computer resources. Now, user can request different type of services. Like if you want computation, you can ask one of the very popular service called Amazon EC2, called as Elastic Compute Cloud. If you need storage, you can go for Amazon S3, called as Simple Storage Service. If you need security, you can go for Amazon IAM, that is Identity Access Management. So based upon your request, the cloud service provider is going to provide you the resources. And for these resources, you are going to pay for it. Okay, whether it is a very large resource, large amount of resources, or it is a very tiny resources, whatever may be the scale of resources, these resources will be provided to the user based upon its requirement. So cloud can host a variety of different workload, whether it is a very heavy workload or it is a very small workload. Any type of workload can be handled by the cloud. And many articles also mention that we have unlimited resources. In fact, there is no call as unlimited or infinite resources, but the limit is so high we cannot reach to that particular limit. That's why we say that we have unlimited resources in the cloud. Whether you need 10 resources or you need 1 lakh resources, all these things can be provided by the cloud. So there are different ways we can ask these resources to the cloud. We can go for an interactive mode, or you can go for a batch mode for hosting the application or deploying your application. Now there are several characteristics you can find in the cloud. Basically, as for NIST, National Institute of Standard Technology, US, they specified 5 different characteristics of the cloud. First one is on-demand self-service. At any point of time, you need any service, whether it is related to a analysis or it is related to a security or it is related to storage or computation. You can simply create an account in a cloud service provider. You have to give your basic details, including your payment information. So the service will be provided to you as per your demand. Whether it is a late night or it is a early morning, doesn't matter. Similarly, broad network access, it says that any device which is able to connect with others through internet, whether it is a smartphone or it is a personal computer or it is a workstation or it is a server or it is a supercomputer, any device having capability of connecting with others through the internet, through which I can able to access the cloud resources. And there is a very large pool of resources is available in the cloud, and based upon the user requirement, the amount of resources will be released with minimal management. It will not take a longer period of time to release the resources. With minimum effort, it should be released to the user. And whether it is a small amount of resources or a large amount of resources, at any point of time I can increase or I can decrease the resources. That's why one of the characteristics says it is rapid elasticity. Like today I am starting a company, I need, let's say, only 5 servers, because I am not sure that whether my company services will be liked by the user or not. And I have seen that, let's say, tomorrow I have seen that there is a anonymous request from various users. So I want to expand my infrastructure from 5 server to, let's say, 20 servers. And let's say, oh, after 1 week or 2 week of time, I found that there is no interest in this product, then again I can scale down from 20 servers to the 5. So this shows a concept of elasticity. Is when required, I can expand the resources, and when required, I can reduce the number of resources based upon my demand. And every services in the cloud is measured. Okay, every services in the cloud is measured in terms of some unit. Like if you talk about our mobile plans are charged nowadays with 28 days or 84 days. or 90 days, something like that. So when you are using a cloud based services, how your provider is going to charge you? Provider may charge you per hour basis. Provider may charge you in a subscribed basis. Provider may charge you tiered basis. Tiered basis means like our electricity bill. If you see, if it is in the range of let's say 0 to 200, a different charge is a charge is mentioned. If it is exceeding 200 but it is less than let's say 300, a different charge is given, and above 300 again another charge is. So this is called as a tiered basis. So that way we can charge to the user. Now when you talk about the global cloud marketplace, like when we go for a marketplace, we are the buyer, and that marketplace the people are called as seller, right? So we have some requirement, and seller says also different product with different requirement. So when the buyer and seller meet at one point for exchanging the resources, I can say, because we are not purchasing these resources or buying these resources, rather than exchange of resources for some period of time, then global cloud marketplace came into picture. So if you go for global cloud marketplace, different users have different requirements. For example, as a user, I may have a question that I need to grow my infrastructure, but I do not know for how long I need that particular infrastructure. So global cloud marketplace can provide me some resources in line with my requirement. Similarly, another user can say, I cannot invest in the infrastructure because I have just started my business. So I can get also resources. On the other hand, in the provider perspective, one provider may say, I have a very large number of infrastructure and I want to rent this infrastructure. Or I have surplus infrastructure. I want to provide these resources to some user for which I am going to get some amount, get some money, right? So all these are connected to each other through a global cloud marketplace. But before providing any kind of services, so a agreement is signed between user and the provider, which we call as service level agreement or SLA. And in SLA perspective also, the terms and condition, like whenever we purchase a particular product, we get a warranty card. That warranty card is also having certain terms and condition, and you are given with let's say 6 months or 1 year or 2 year or 3 years to get that particular service if it is not functioning properly. So in service level agreement also you have different clauses, and security plays a also very important role in the service level agreement, right? What kind of security policies you are going to use, what are the different type of services you are using, who is responsible for what kind of security requirements, that also mentioned in the service level agreement. Now why cloud becomes a very popular paradigm is that it enables that same hardware can be used by multiple people by applying virtualization technology. So virtualization technology enable the multiple users to use the same computer hardware. So each and every user that are participating in the cloud, mostly they create a virtual machine. These virtual machines are created by taking the resources of a physical machine. So for example, if you see this very first diagram, which I mentioned here is multiplexing. So what happened here? I have computer storage, and on top of computer storage, I have hardware, and on top of hardware, in order to implement this virtualization technology, I have virtual machine manager, VMM, virtual machine manager, or it is also called as hypervisor. Why hypervisor is there above the hardware? It can create a virtual machine, it can manage a virtual machine, and it can perform certain tasks in the virtual machine. Like you can see on top of virtual machine, you have two operating system, and these operating systems are considered as my guest operating system. Like there is a user who wants to use some resources. That's why I have created one virtual machine, And in that virtual machine, I have operating system, and the user is running some kind of application on top of the operating system. There is another user who wants to be some resources. I have created another virtual machine on top of the same physical machine, and the user is running a different set of application on top of it. Now you can see two different users are using the same computer hardware. So obviously, if a one user is using, the utilization is some up to some extent, then definitely that particular utilization is going to be increased if multiple users are using the same hardware. Now it may happen that sometimes I want to expand my infrastructure. If I expand, the underlying hardware is not supported. As a rough example, I can say if my computer hardware is having, let's say, a 4 GB. Okay, 2 GB is taken by this particular user and 2 GB is used by this particular user. Now, this user wants to expand the infrastructure to 4 GB. So I cannot expand because my physical machine is having 4 GB, but the sum of the current requirement is 6 GB. So I need to decide that where I am going to migrate this particular virtual machine. Migration is the process for moving a virtual machine from one host to another host. The host from which I am going to migrate is called a source. The source, the virtual machine is going to be deployed in a host that is called as target host. So basically, we are moving from a source host to a target host. Now, when we talk about migration will be done over a network. So there also security plays a very important role. If we are not using appropriate security measures, so while you are moving the virtual machine, it may be captured by some unauthorized persons also. So overall, such type of migration is categorized into two types. One is considered as hot migration, another is considered as cold migration. Hot migration means I don't want to stop in between. That means if I am running a particular process or a application, I don't want my applications to stop for some period of time to resume it in a destination host or a target host. Like you are watching something in your mobile phone and you want that the same thing should replicate to your smart TV. So it immediately you can do this one. So in that case, we call that is a live migration or it is a hot migration. But whenever interruption is affordable, we can stop in a particular resources, we can keep in a particular storage, and we can find a destination host. After finding the destination host, I can resume it. Just you can see in this particular situation. I have suspended a particular virtual machine. I kept the virtual machine in the storage. Then later point of time, I identified another host and I am resuming that in that particular host. So if such type of migrations are happening, that is called as cold migration. So whether to go for cold migration or hot migration, it depends upon the different type of application. Like when you go for hot migration and live migration, there is no interruption. There is no, you can say no, you can say the application should not be stopped for some period of time. But when you go for cold migration, we can stop and we can resume at a later point of time. So this technology enable us to uh, use the resources properly. Okay, or multiple users can use the same resources in order to utilize the resources properly. Now if you go for as for the requirement mentioned by Professor Rees, he mentioned that in order to use any kind of services, whether it is a security related services or it is a computing or a storage related services, you need some basic requirement. Like you need a credit card or debit card information. Like if you provide this payment information by creating an account in Amazon Web Service, Amazon Web Service is providing you some free services. Every services you will get some free quota. Like if you talk about Amazon EC2, Amazon EC2 is giving a user 750 hours per month. And if you calculate number of hours per month, it is coming as 720. So why Amazon is giving 750? because if you run multiple instances at the same time, so in a month I want to run two different instances, it will be 720 hours into 2. So you will exceed the free quota of 750 hours, right? So up to 750 hours of resources is free in Amazon EC2. No doubt the resource is not that much bigger resources, or the instance is not that much powerful, but there is a small instance that you can use for 750 hours per month. Okay, and you need a web browser, like we have Mozilla Firefox, we have Google Chrome, we have Internet Explorer, through which we can access the cloud-based services. Like this WebEx meeting is also running in the cloud, and you need not require any capital expenditure, and you pay only for what you have used. So every month Amazon is going to bill based upon your usage, and at the end of the month the bill is generated, you have to pay for it. So when we talk about such type of services, so the services are again divided into different type. So the classes of cloud depends upon what are the different type of cloud we are going to use. For example, if I say that where I am going to place the cloud, whether I am going to place the cloud in my organization or outside the organization, and who is the intended user of that particular application. Based upon the deployment type, broadly the cloud is divided into four types. One is the public cloud, another is the private cloud, community cloud, and hybrid cloud. So public cloud means anybody can use that particular service, like anybody can create a Google account and use the services. So the service is open to everyone. But when you go for the private cloud, it is not available to everyone. Like in a particular organization, if some cloud is used, that is restricted to the stakeholder of that organization. So maybe you can talk about student, or you can talk about faculty member or alumni. So all these stakeholders only can use this particular cloud. So obviously private cloud is secure compared to the public cloud. And when we talk about the public cloud, the question arises that if I am running a particular organization, whether I am capable to create my own cloud, own private cloud. So most of the cases the answer is no. So if I am not capable, or my employee are not capable to manage these services, so I need a third party who is going to manage for it, right? So such type of cloud is called as off-premises private cloud, because there is a third party who is managing the cloud on behalf of a enterprise or an organization. But if I can manage my own infrastructure, I have that skill, I have that capability, then I can go for a on-premises private cloud. But in any other case, you can see sometimes we have a project in which multiple organizations are collaborated together to execute something, to achieve some particular government common goal. Like let's say all the governments, state governments, they initiate some kind of project which they need to execute combinedly to achieve a common goal. So in that case, we can go for community cloud. And if any combination of these clouds you can use, that is called as hybrid cloud. So security policies will be different with respect to the deployment model. Similarly, when we talk about what kind of services we are getting from the cloud, basically the services of the cloud is divided into three parts. One is infrastructure as a service, platform as a service, and software as a service. Okay, infrastructure is nothing but the bottom layer, platform is nothing but the middle layer, and software as a service is considered as the top layer. Like we talk about Amazon EC2, we talk about Amazon S3, or we talk about compute, or you require storage, you require network. All these are coming under the infrastructure as a service. Then platform is providing you an environment to host a particular application, like middleware or deployment of a particular application, right? All these, like operating system is also a platform. So if you need a platform to run your application, then you need platform as a service. And if you want any software, like Facebook can be considered as a software, Twitter can be considered as a software, you can say all these things which you are using, different website, Webex, or you can say Google Meet. All these are nothing but the software in which you can get a particular service. Gmail is also example of a software as a service. All these are treated as a software as a service. So out of these three services, if you have infrastructure, you can ask for platform as a service and software as a service. But if your organization do not have any type of service to host, you can take infrastructure, platform, and software, all these three things from the cloud. At a later point of time, people have come up with a different type of services. Like those people who are more focusing on the database, they come up with a database as a service. Those people who are focusing on, let's say, sensor, they come up with sensor as a service. So there are different type of services came into picture, which is called as everything as a service or anything as a service, which represent as a XaaS. Now when you go for this service perspective also, you need to assure that which part will be responsible, which security requirement will be fulfilled by your user, which security requirement is responsibility of the user. We cannot say that if I am using the cloud or my cloud service provider is only responsible for everything. That is not correct. So we have to ensure that which part can be taken care by cloud, which part taken care by the user itself. Now, this is a very simple architecture which is called as market oriented cloud architecture, having four different layers. The first layer is called as user or broker, because whenever you are using a cloud services, if user is a layman, then on behalf of user, there is a broker who can interact with the cloud services, or who can interact with the cloud service provider. So whenever a user or a broker submit a particular request, the request reaches to a service request examiner and admission control unit. Service request examiner, what it is going to do? It is going to check that whatever requirement the user asks, whether we can fulfill that particular requirement or not. If we cannot fulfill the requirement, straight away I am going to reject that particular request. It is better to reject the request rather than violating the terms and condition, right? If I agree to provide the resources at later point of time, if I am not able to provide the resources, then it leads to violation. So we have to ensure that the resource that is asked by the user, or whatever the requirement the user has given, we should fulfill that particular requirement. And admission control unit says that how many users I can, how many peak users in a peak hours, how many users I can accommodate. So this unit is just like a entry gate to enter into the cloud. So there are other units that are also available in the service level agreement resource allocator layer, like pricing mechanism. Which pricing mechanism I am going to charge to the user, whether it is per hour basis, or it is subscription basis, or it is tiered basis, or it is a lump sum basis. So that need to be finalized through the pricing mechanism. Normally, this pricing mechanism is broadly divided into two parts. They may be charged based on peak hour and off peak hour. Normally, 12 p.m. to 12 a.m. is considered as peak hour, and 12 a.m. to 12 p.m. is considered as 12 a.m. to 12 p.m. is considered as off peak hour. Pricing can be charged based upon the fixed price or variable price. Pricing can also be charged based upon the demand and supply. Okay, if demand is more, supply is less. So obviously price is going to be increased. And IRCTC has a premium Tatkal scheme. It also based upon the supply demand scheme. Now there is a VM monitor unit. The VM monitor unit check the status of the virtual machines that are created for the user, whether the virtual machine is running any particular application, or the virtual machine is idle, or the virtual machine in sleep state. All these things will be determined by this VM monitor unit. And on the contrary, you can see there is another unit called a service request monitor unit. It checks the status of each and every request submitted by a different user, whether the request is honored, or the request is queued, or the request is executed, okay, or it is finalized. All these types of status you can find from the service request monitor unit. there is a accounting unit, and in order to move from one unit to another unit, we have a dispatcher unit. So all these are a part of our service level agreement resource allocator unit. And before agreeing to a particular request, you should check that quality of service requirement of each and every request. What is the quality of service requirement? Suppose a user asks that I want the downtime should be less than 5 minutes per month. So whether I can fulfill that particular request or not, that you need to check. That is the quality of service. If quality of service requirement is not satisfied, simply the request is rejected, or we can go for the process of negotiation. Through negotiation, we can provide. Through negotiation, we can relax that quality of service requirement. And you can see there is set of virtual machines. There is a layer for virtual machines, and these VMs are created based upon the resources of the physical machines. How many virtual machines we can create? That depends upon the capacity of the physical machine. Like here you can see this particular physical machine, I'm taking the resource and I'm able to fulfill the requirement of the user using two virtual machines. This is another physical machine which I have created three different virtual machines. Okay, aggregating these three virtual machine, the resources should be less than equal to the size of the physical machine. So this is a overall architecture of you can say market oriented architecture, which is broadly divided into four different main entities. What is user broker? Another is service level agreement resource allocator. Another is VM. Another is physical machine. Now there are several success stories you can see in cloud. Like I am giving three examples here. There is a newspaper called as New York Times. New York Times newspaper, early days newspaper was coming in printed form, hard copy, right? But nowadays newspapers are coming in printed form, as well as they are available in a portal. You are given with a username and password through which also you can read the newspaper. So New York Times wants to create a web-friendly portal in which all the newspapers of the olden days, they need to be available. So for this, you see that there are several editions are there are many years, and so many years are there, this many newspapers are there. They want to make it available in a portal and then don't have any infrastructure. So what they did, they hired Amazon EC2 for computation, Amazon S3 for storage, and within 36 hours, they are able to create that particular portal and make it live for access to the user. It is a real success story behind the cloud. Similarly, there is a company called as Animoto. Animoto takes different pictures and create a video. So Amazon also, Animoto also do not have any infrastructure. So they have used Amazon Web Services, and through Amazon Web Services, they hosted their applications. So initially they have taken only 70 servers because they are not sure about whether the user will have interest to their product and services. And later point of time, they have seen that there is an enormous request to their site. So they increase the number of server from 70 to 8,500. That is also one success story behind cloud. There is another company called as Little Floppy Toys. So Little Floppy Toys, this particular company, it is just like a startup company. So this company is taking the GPS location. Based on your GPS location, it is going to suggest that which one is the nearest bicycle rental service shop. So that you can go to that shop and you can hire a particular bicycle. Okay. So they developed this application through Google App Engine. Google App Engine provides them a platform to host the application, and they are available in the market within 1 week. So all these applications shows that irrespective of the amount of resources required by a particular enterprise or organization, cloud provides different type of solutions. So although we have seen that there are several advantages and there are various companies have interest in the cloud because of the cost effective services, because of the rapid elasticity, because of the measured services, because of the broad network access. So cloud faces a lot of issues with respect to security and privacy. Why the security privacy plays a very important part? As I mentioned that if you look into the cloud infrastructure, from a user perspective, it is a virtual infrastructure. But from a provider perspective, it is a real infrastructure. So in order to provide any kind of services, you need integration of this real infrastructure with the virtual infrastructure. So when we integrate this real infrastructure with virtual infrastructure through internet, security is a really a challenge. Not only security, because as I mentioned that servers are where the servers are located, who is maintaining that particular server, all these things are not known to the user because users are treating these as virtual resources. So legislation point of views also it plays a very important role. Like different countries, different continents, they have different legislation. So all legislations are not same. So when we make this type of infrastructure, when the user belongs to one legislation and provider belongs to another legislation, it plays a very important challenge that how to integrate different legal frameworks or regulations which is governing how the cloud data is stored, how the data are processed, how we can protect that. That is creating a challenge. So we have to ensure that the compliances should meet all the locations, and it protect user rights, it enforce an accountability, and it build trust among the user to use the cloud-based services. So there are several legislation you can find. Like if you go for European Commission, they have a legislation called GDPR. If you go for US, they have a legislation called as HIPAA. If you come to India, we have IT Act. So different countries are having different legislation. So the cloud service provider should focus on how to integrate different legislations or how to satisfy the requirement of different legislations so that trust and accountability can be built. Now we can say that if you go for cryptography and network security, we have seen there are several protocols are there, right? These protocols ensures that when the data is moved from one particular host to another particular host, and nothing is going to be violated. Whether we talk about confidentiality or we talk about integrity or we talk about authorization, authentication, nothing is going to be violated. So when the data is in transit from a particular organization premises to the cloud. Organization premises is called as private premises, and I want to move the data to the cloud. So in transit, I can apply different cryptographic methods which are well defined. But the problem comes when I am going to process this data. When I am going to process this data, you have sent some data to the cloud, but now you want to process this data using, let's say, Amazon EC2. So when you are going to process this data, you have to decrypt that particular data. Data cannot be processed in the encrypted form. So this is the major weak point where a attacker can launch attack to get some uh, information which can be used in later point of time to apply any kind of attack, or confidentiality can be violated by that particular unauthorized persons, right? So, also virtualization plays a very important role. Through virtualization, multiple users are using the same computer hardware. So, if multiple users are using the same computer hardware and one of them may be a intruder or an attacker. So, there also the data can be easily captured by the attacker. There are many providers are there which we rely, like day by day, different type of applications we are using. And these applications require our Google credentials, basic informations. We need not enter all the basic details. All these basic details can be retrieved from your Google account. So it may happen that the provider of that particular application is a malicious provider. So in that case, the data can be captured by a malicious provider also. So although virtualization allow capturing transparently the memory pages of an instance, but we are not sure that whether the data which we are sharing, it may be captured by some provider who are malicious, or malicious provider can capture the data and may misuse this particular information. Now, if you see a typical scenario, like if you talk about US legislation, as I mentioned that different countries are having different legislation, right? Like United States also having different type of legislation. It is two legislations are there. One legislation with respect to healthcare data security, another legislation with respect to consumer privacy rights. Okay, so if you go for US legislation, US legislation has given extreme power to their government agencies to acquire confidential data. If they find some suspicious information, if the government agencies found some suspicious information, they can acquire this confidential data without any permission. They can track this one and get this particular information, because this information may lead to nation security issues. So they have given power to extract that particular data, right? Now when we talk about cloud, we cannot assure that US government data will be retained in the geographical boundary of that particular country. It may happen that US data may be stored in Europe. Many users are there. Some users data may be present inside their organ, inside their country, and some users data may be available outside their country. So when the data is stored outside the country, their government agencies has no role to control that. That means US government has no control over it. So in that case, US legislation, even if US government agencies try to extract, okay, they tries to extract the information will not be available. So that is actually a really challenging. Now, if you talk about European common market, if you go for European common market, in their market also they have two different legislation. When the data is stored somewhere, there is a legislation. When the data is in transit, there is different legislation. Okay. See, with respect to continent, country, there is different legislation. But within a country also, what is the position of the data? Whether the data is kept somewhere or the data is in transit. Based upon that also, there are different type of legislations available. So when the cloud computing came into picture, right? So we have to deal with multiple jurisdictions, multiple compliances in order to make it available everywhere as per the user demand. Not only that, there are several other challenges also you can find, which is maybe a non-security related challenges also. Like if I need customization, I need a different type of authentication mechanism. I want different type of security protocols. So I have to ensure that my cloud service provider is providing me that type of customization. If customizations are not provided, so whatever the policies the cloud service provider is providing me, I have to use that. I cannot enforce my policies. That is also one of the challenging part. Similarly, you can see that cloud services, whenever we use, whether we talk about security, privacy, or anything, so we know that internet connection plays a very important role. So if the latency is more, then user will not happy to use that particular cloud-based services. Like if you want to open your email services and email service is opened after 5 minutes, then as a user you will not be happy because the latency is more. So we have to ensure that these services should be provided to the user. These services are provided to the user without any interruption. So we have to ensure that there is a stable internet connections to get any kind of services in the cloud. Now, when we talk about the architecture of the architecture of the cloud faces different open challenges. In fact, these challenges exist now also. The first challenge, which is related to the architectural design, is that is called a service availability and data lock-in problem. Service availability says that the required services will be provided to the user 24 into 7 without any interruption. But we know there are different type of attacks. If such attacks happen, we cannot guarantee the availability of the services. For example, you know about the denial of service attack. As the name suggests, the service is not provided to the intended user because of this particular attack. And this attack is not initiated from one particular system. It may be applied from different system and from different location. That's why this attack code is also called as distributed denial service of attack. So whether it is a DOS attack or it is a distributed denial of service attack, it provides a question on the availability of different type of services. There is another problem that is called as data lock-in problem. What is a data lock-in problem? Data lock-in problem says that suppose I am using a cloud service, like most of the time nowadays we use Google services. We are very much habituated with Google services, right? And tomorrow, if a new service is coming, as a customer, I will hesitate to move to that particular service because I have already compatible with the existing cloud service provider and type of services provided by that particular provider. So even if other provider provides you a lot of flexibility, it is difficult to move from our current provider to another provider. So customers are dependent on a single cloud provider. They cannot easily move to other provider. Even if you decide to move to other provider, the APIs, the libraries that are used by different provider are different. Okay, the APIs that whatever used in the current provider, it is different from other provider because there is no standardization. So ultimately, the vendor has locked you, or your data is locked with a provider which enforce you to continue the service rather than moving to other cloud service provider. So that is one of the challenge. Like if you take an informal example, nowadays many shopping malls are asking you mobile number when you check out and you pay the amount. So they created a wallet in your mobile number. And let's say you are not visiting to that shopping mall frequently, then that wallet is of no use. And whatever points you have earned in that wallet, that cannot be transferred to other shopping malls. So that is also an example of a lock-in problem. So the data lock-in problem, or you can say vendor lock-in problem. Similarly, when we talk about privacy says that somebody's private information should not be available. So when the sender transfer the data to the receiver, so the malicious user or the attacker, they can launch different type of attack to get the informations, confidential informations. Like one of the attacks which we have seen, that is called as man in the middle attack. Man in the middle attack, there is a third person between two different person who is transferring the message. It is observing their pattern and it is trying to intercept something, so that the sender will feels that it is originally originated from the receiver, or receiver feels that it is originated from the uh, sender, right? So all these type of things happens in the between the two different parties. That's why we call that is man in the middle attack. So that is also one of the challenge, because between two different servers we need to migrate the virtual machines, we need to transfer the informations. So if it is easily captured by attacker, so man in the middle attack can be possible. The third challenge is called as unpredictable performance and bottleneck, because you see multiple virtual machines are hosted on top of the same physical machine. So they share the CPU, they share the memory, but input output is not shared between two different virtual machines. So always achieving the parallelism is not possible. That's why we say it is a bottleneck. We cannot exceed a particular limit, right? So there may be unpredictable performance and bottleneck with respect to the architecture. Similarly, other challenges you can see here, data consistency is a challenge because the data is kept in multiple location. Like if you go for Amazon, Amazon has mentioned that whatever informations that are available or you talk about our email system. Our emails are stored in 3 different locations, because it may happen that there may be a natural calamity. It may happen that there is a failure. So if it is a failure happen in one location, still your data is available in 2 different locations. Okay. So when the same data is available in multiple locations, so we have to ensure that consistency among the data. That is also one of the architectural challenge. Similarly, scalability, interoperability. Like a particular application may run in a particular virtual machine. So when I'm moving that virtual machine to on top of another physical machine, it should be interoperable. It should operate. Right? If it is working in one particular theme, it should work in another theme. Or if a particular software is running in Windows environment, if I'm changing it to Linux environment, it should work in that environment. So that is also one of the challenge. Similarly, standardization is also plays an important role. Like I told you, this legislation case, if the standardization is maintained across the globe, then it is easy to provide the different type of resources. That's why many providers are provided open virtualization format, which is called as OVF. It is an open, secure, portable, efficient, and extensible format for packaging and distribution of the virtual machine. So this format is used across the virtual machine cycle, so that the same thing can be maintained by different providers. Okay, that's why OBF is used. Like Amazon case, different instances are there. These instances are having some kind of template. So you have to use one of the template to provide the different type of services. Similarly, software licensing, reputation sharing is also one of the architectural challenge. Now, you know that if a unauthorized user or a attacker is entering into the system, they can inject some kind of virus which leads to some kind of epidemic. So if a virus is injected, okay, let's say in the banking network, then the banking network will not be available for a couple of hours. So it leads to $1 billion loss. If network service is not available, then there is no transaction. If there is no transaction, it leads to a huge amount of loss. So how it is going to happen? It is happen with respect to 3 different security requirements. If we ensure that these 3 security requirement is maintained properly, then we can ensure that such type of incident may not happen, or may not lead to an epidemic. So what are the 3 security requirements? First one is called as confidentiality. So if there is a loss of confidentiality, that means the information is leaked somewhere. Like if there is a confidential information between the sender and receiver, if the same information is available to a third person, so it is information leak which may lead to the epidemic. Second security requirement is called as integrity. Integrity ensures you that the data is not modified. Data is not modified. Like if a third party is involved, or third person has entered into the system and modified modified some of the content, so we can say integrity is lost. Like the popular virus called as Trojan horse. This is an example of the loss of integrity. Sometimes services are spoofed. We call that as a service spoofing attack. Is also an example of loss of integrity. Similarly, third is called as availability. Availability is lost if we launch a different kind of attack like denial of service attack and distributed denial of service attack, which is initiated from different location by targeting a particular victim, right? So these 3 security requirements must be ensured, or in short, this is called as CIA, right? That is called as confidentiality, integrity, availability. Apart from this, also there are some other security requirements need to be satisfied, like authentication, authorization. Authentication enable you to authorized user can only enter into the system. Authorization means you are delegating the power to another user. Like in place of the user, the broker can also interact with the cloud system, right? So authorization is also maintained properly. If it is delegating, you have to ensure that the authorized user only entering into the system. or the delegated user is entering into the system, not any malicious one or the attacker one. Now, here you can see there are different type of attacks that are possible if you lose confidentiality, integrity, availability, and authentication. Okay, for example, eavesdropping, like in email, in many ATM counter, although one person is allowed to enter into the ATM hall, let's say more than one person is available inside that ATM hall. Then, if more than one person is available in that hall, it may happen that another person can see what other people are entering. So it leads to eavesdropping. And sometimes in the network, there are many attackers, they analyze the traffic, and based upon that they inject different type of attacks. So if loss of integrity happen, or we call that as a information leakage, these are the possible attacks. These are the possible attack which happens with respect to the loss of integrity. Similarly, here you can see I'm not going in details of each and every attack because these attacks are also same as our network-based attacks. So you can see loss of integrity leads to this one, loss of availability, loss of or improper authentication. All these leads to this type of attacks. So some of these attacks I'll tell you one by one. There is a very popular attack in cloud because of confidentiality that is called as cross virtual machine attack. Like I told you, there are two different users. Assume that there are two different users. They are using the same computer hardware. Let's say this is the computer hardware. On top of the computer hardware, there is a virtual machine manager, and this virtual machine manager has created operating system for this user, operating system for this particular user, and this user is running an application. This user is also running one application. Now there are multiple virtual machines running on top of the same physical machine. So out of these two users, if one of the user is a malicious user or an attacker, then it may happen that there is a virtual machine attack, cross virtual machine attack. If one of them is a attacker and they found that who are else using the same computer hardware, attack becomes much easier, right? So we have to ensure that such type of attacks are avoided. But sometimes we call that as a VM co-residence attack. VM co-residence means you can see multiple independent customer share the same physical infrastructure. So VM co-residence has raised certain security issues such as cross virtual machine attack. Similarly, you have to ensure that in order to make it a trusted cloud computing environment, or in order to improve the trust, you have to believe your own system admin or your provider. But if your provider is a malicious provider, then you cannot create a trusted cloud computing environment. Similarly, you can see there are different other types of attacks are also possible, right? If we compromise on integrity, like loss of physical control. So you know that data and program, all these are outsourced to the cloud server. Neither the data is stored in user end, nor the programs are stored. Everything is sent to the cloud server. So if the cloud server is not maintaining the disaster recovery, which we call as DR, then if the data and programs lost, or they may be altered by an unauthorized person, or if the cloud service provider itself a malicious one, they can also get this particular data, because these data and programs are not controlled by the user because it is outsourced. So it is very difficult or impractical to ensure that the data and computation integrity is maintained using the traditional methods. There may be also dishonest computation. Like I need some computational resources to execute some of my application, but an attacker has injected something in which the computation is controlled by that particular attacker. So such type of things are called as dishonest computations. So in order to ensure that the security is maintained, in many cases there is a third party auditors they have to certify that there is no data is lost and there is no data manipulation. Similarly, availability weights is also it is challenging, right? If a availability is compromised, then even if you have a sufficient number of resources, suppose I have taken 7,500 servers like Animoto, and the bandwidth is compromised or availability is compromised, so I am not going to use my all the servers. Okay, and in many cases, the pricing related to the cloud pricing mechanism, because different providers are providing different pricing mechanism. Different type of pricing mechanisms are there. For each and every type of pricing mechanism also, every provider has a different requirement. So there also one type of attack is possible, that is called as ardent resource consumption attack, or called as FRC attack and FRC detection. So one malicious attacker can reveal the cost or accounting part of a provider to other cloud service provider, so that one provider can take advantages of that pricing mechanism to get more number of customers. So such type of attacks are also possible. So cloud customers are financially responsible for the services they use. So they have to also ensure it is not always the provider is responsible for all the security requirements, but also you have to see that for which type of services provider is responsible, for what kind of services the provider is responsible for the security requirements. So sometimes attackers also, they have incentive to harass the billing process by exploiting the pricing mechanism. Okay, so bandwidth under provisioning attack also I told you, because of DOS attack and DDoS attack, it is not possible to utilize the bandwidth properly because the service is not available. And related to the copyright, like many times a intended user or the paid user, we call that as a colluder also, they have the license to use a particular cloud licensing software, but they illegally share the credential to other users who are unpaid users, or they are called as pirates. Okay, early days also, you know that when we have a software, the software is again the software is purchased by someone, and the same copy is given to others, so they are able to use that particular software. So nowadays there are token-based mechanisms are there to avoid this type, or there are different type of timestamps are also there, through which we can avoid the pirates to use the cloud licensing software. So overall, the defense system of the cloud is categorized into three parts. One is called as the first generation network defense technology, second defense, and third defense. What happened in first defense? It is the earliest one, which says that we have to prevent or avoid the intrusion. When you are using the cloud-based services, we have to prevent that uh, no intrusion is entering into the system, or no attacker is entering into the system. You have to prevent it. But in the second generation of the system, we are not only focusing on preventing such thing, but also we want to detect the intrusion in a timely manner. If you detect a intrusion in time manner, then only the confidentiality can be maintained. But in the current generation of defense system, we don't want only prevent and detection, but also if an attacker is launching any kind of attack, then we have to give intelligent response to that particular attack. So that brings the third generation of defense system. Now coming to, there are three different type of services, what I told you: infrastructure as a service, platform as a service, and software as a service. And I told you three security requirement: confidentiality, integrity, another is availability. So when you go for infrastructure as a service like Amazon EC2 or Amazon S3, your provider is not responsible for confidentiality. So if confidentiality is compromised, just like eavesdropping, then user is responsible for that. Okay, IAS user is responsible for that. But if integrity is lost, then provider is responsible. So you can see Some requirement the user is responsible, some requirement the provider is responsible. But when you go for platform as a service or you go for a software as a service in which confidentiality and integrity is responsibility of both user and both provider. So whether your provider is responsible for it or you are responsible for it, it need to be clearly mentioned in the service level agreement. So at any case, if any type of problem happens, then you will be able to identify, okay, you will be able to identify who is the intended or who is the person responsible for this particular attack. So why don't we maintain our own security? Why don't we go for the traditional IT security or the traditional way of managing our infrastructure with respect to security privacy rather than moving to the cloud security? The answer you can see here. When you go for your own data center, you have in-house data center, so you cannot rapidly scale it. But when you go for cloud security, you have third-party data centers, you have agreements, so you can extend it to any level. Similarly, the upfront cost, if you see, is very high. If you are maintaining your infrastructure, if you maintain your infrastructure, you manage your infrastructure, and you scale your infrastructure, it is very high cost. But in cloud case, it is low upfront infrastructure investment. And efficiency wise, security mechanism, security protocol, if new security protocol came into picture, if you want to integrate, so you have to do your own, so your efficiency is low. But in the cloud based case, you can immediately, if that particular protocol is there, we can integrate it. So compared to the traditional IT security mechanisms, cloud security mechanism provides you the better solution with low cost. So although security is very important, but you can see there is always a trade-off between security and security privacy with the computation. Like if I use a protocol which takes much time for authentication, then computation is it is impacting my computation. So security can safeguard your data, privacy can safeguard your private information or identity. But there is always a trade-off between the cloud-based services, because why you are going for cloud-based services? You will get better efficiency, you will get faster resources compared to your in-house infrastructure. So on the other hand, when we look into the security perspective, security protocols need to be checked to check that whether a authentication takes time, check that whether integrity is maintained takes time. So we have to ensure that security and privacy protocols, they are not dominating the cloud services, efficiency of the cloud services. So there is always a trade-off between cloud services and security. We cannot say that efficiency can be compromised. We cannot also say that the security privacy can be compromised. So that's why people have come up with different lightweight protocol to find the solution. So here you can see with respect to the service model, with respect to the deployment model, and with respect to some basic components of the cloud, you need different type of security mechanism. Like I need infrastructure security, I need software security, I need storage security, I need, let's say, network security. So with respect to different components of the cloud or different type of services, we have different privacy mechanism and security mechanism. So here I have listed there are different security and privacy based algorithms, and most of the researchers nowadays are focusing on more or less these type of privacy or security based algorithm. And one of the very popular algorithms nowadays people use, that is called as attribute based encryption. Okay, attribute based encryption. Okay, it is very popular. So as the name suggested, I focus on a particular attribute. Right, for example, if you have a data and you want to apply some kind of encryption where access is granted based on a user attribute, like I can say access is based upon the role which is given to given in a educational institute, whether you are a student or you are a faculty member or you are in a administrative role. Access can be given based on the department, and access can be given with respect to the clearance level. So here you can see there are two type of attribute based encryption I am highlighting here. One is called as uh, key policy, based attribute based encryption, which is called as KPABE. Another is called as ciphertext policy ABE. So when you go for KPABE, access policy embedded in the user's private key. You know there are two different kind of key we are using in asymmetric key system. One is the public key, another is the private key. In user private key, if you embed it, that is called as key policy based attribute based encryption. But when the SS policy is embedded in the ciphertext, we call that as ciphertext based attribute based encryption. Okay, like if you go for key policy based mechanism, I can take a data with medical data, I can take a data with research data. So when somebody is searching, they have to write medical and research so that text can be extracted. But in the case of ciphertext, user's private key contains attributes. For example, I will mention that role is the doctor, and let's say department is cardiology. So based upon that, only the user with matching attributes is going to be extracted and their key is going to be decrypted. Like that, you can see there are several type of security and privacy policies are developed in the recent literature. Yeah, here you can see I suppose Alice want to read a particular message. Okay, instead of saying that only Alice can read this, that means I am violating the privacy. So I am mentioning that anybody whose role is a doctor and department is cardiology, so they can read this particular message. So I am not specifying a particular person name who is satisfying this particular condition. They only can access the particular data. So this is an example of a attribute based encryption. Attribute case encryption, I can go with private key or I can go with ciphertext. Similarly, there is another type of encryption nowadays very popular, that is called as searchable encryption. Okay. So searchable encryption allows you to search over encrypted data without first decrypting it. In the traditional process, what we are doing? We are doing the encryption followed by the decryption. So it allows you to search the encrypted data. Encrypted data cannot be searched. Encrypted data cannot be searched without decrypting. So this encryption technique allows the user to search over the encrypted data without decrypting. Because why it is important? The reason being it is important is that the cloud servers are untrusted. Although the data programs are outsourced to the cloud, I cannot fully trust on the cloud. That's why, although cloud is a very popular paradigm, but if you see the military organization, banking organizations, they have their own cloud. They are reluctant to use the public cloud service providers. So, in the case of searchable encryption, users can query encrypted data securely, right? So, this is very, very useful when your data is not with you, it is there in the virtual infrastructure, especially in the cloud, and you don't want your cloud service provider at any cost read your data. In that case, searchable encryption plays a very important role. But always there is a challenge because there is a trade-off between security and privacy. Now coming to another two interesting part, one is called as trust, another is called as reputation. Okay, so the trust between service provider and service consumer or user, cloud user, will increase if the service is provided without any interruption. But trust is considered as a social problem. Like if you see, if I ask you whether you trust this e-commerce site or not, it is a social problem. It is not a technical issue. There may be another e-commerce site which is recently launched providing good product, but we don't trust this one because it is new. But existing e-commerce sites, we have where we have purchased many items, we have exchanged the item, we have returned the item, we have more trust. So this social problem of trust can be solved using the technical approach. And in order to ensure that there is a trusted cloud system or healthy ecosystem, you have to ensure that there is no violence, there is no cheating, there is no rumor, there is no copyright violation, there is no privacy leakage. then definitely we can build such type of system. And the security and privacy, which we are talking, mostly focus on the logical security. We are not looking into the physical security. But in order to make it trustworthy, we have to ensure that physical security is also maintained. Like all these data are stored in the data center. So when we go for a data center, you can see there may be a chance of physical theft also, not only the logical theft by the attacker. There may be physical theft also. That's why the data centers are equipped with the biometrics reader. Data centers are equipped with CCTV, motion detection sensor meant for finding any man trap within the data center. So not only we are building good security mechanism, but also we look into how physical security can be maintained within a cloud infrastructure. Now here you can see there is a distributed intrusion anomaly detection. Like here you can see there are four different attacker. There is an attacker who is launching a attack from four different locations to this particular victim. So the attack is not launched from one particular location. The attack is launched from different locations, and these are nothing but different type of routers. So basically, it is flooding some kind of traffic to target a particular victim, so that intended users cannot access a particular type of services, or you can say it is a type of distributed denial of service attack. Like you can see, this attack flows through router 7, router 9 to reach to the router 0. This particular attack starts from router 3, moving to router 2, router 1, then it is coming to router 0. Similarly, there is a traffic flow from R6, R8, R1 and R0. Similarly, R5, R4, R2, R1, R0. So finally, all these attacks, okay, malicious attacking flows are reaching to our victim. And this is the trace you can see. This is the attack traffic flow 3 over these routers. So finally, the victim will not able to provide different type of services. Similarly, when we talk about man in the middle attack, you can see here there is a virtual machine monitor. Let it be a VMA. It is hosting one of the virtual machine instance. But this VM instance needs to be expanded. So we have to suspend this particular virtual machine instance on top of this virtual machine monitor A, and I'm migrating that particular virtual machine instance from host A to host B. So when we move this virtual machine instance from one VMM to another VMM, there may be a man in the middle attack. If such attack can happen, then they can modify the virtual machine content or the application state. Okay, so which also impact the trust and reputation, right? If such type of attacks can happen, people will reluctant to use that particular type of services. So many people have come up with different data coloring and watermarking approaches, because early days, if you remember, there are different type of watermarking approaches are there, and like if you take an image and if you put some kind of watermarking, and these watermarked images look similar to the original image, but the confidential information is available in that watermarking images. So in the data coloring and watermarking approaches, each and every data object is assigned with a particular color. So user identification is colored to be matched with the data color. So whenever a data owner is asking to a service provider about a data object, so that will be done with the matching with different type of colors. Okay. So cloud storage providers process for the generation, embedding and extraction of this watermark in the colored items. If it is matched, then only the data can be retrieved and provided to the data owner. Otherwise, the data is not going to be provided. Similarly, another aspect is called as reputation. So reputation focuses on the public opinion. Whether a particular service provider is reputed or not, that is a public opinion. That is not an individual opinion. Whether you trust a particular cloud service provider or not, that is your individual opinion. But reputation comes when many users are interested in that particular type of services. So we can say trust is a very subjective matter. but reputation is more objective or larger opinion. So when we look into this reputation based system, the reputation based system can be implemented in a central way, or they may be implemented in a distributed way. Again, whether it is a centralized way or distributed way, it can be further divided into user oriented or the data center based. Like when we go for centralized system, it is very easy to implement. We can demand more powerful and reliable server resources. But when you go for distributed system, as it is present in different location, it is more complex. Like if you know about eBay and social networks, there is an example of a centralized system, and they are coming under the user oriented. Like if you go for Stanford University has a reputation system called as Eigentrust. That Eigentrust is a distributed reputation system. Similarly, if you go for peer-to-peer system, peer-to-peer system is also able to manage different type of trust. Similarly, peer trust is another system is used in Georgia Institute of Technology for e-commerce application. Power trust is a mechanism which is a data center based decentralized system that is used by University of South California. Okay, so different people have come up with a different type of reputation system. So we have to ensure that the data is consistent across multiple databases to ensure that the reputation of a provider is improved, and copyright protection secures the wide area content distribution. So there may be underlay network, there may be overlay network. So we have to ensure that the overall network is more trustworthy. Then only the reputation of a particular provider can be improved. So with this one, I'll tell you about one of the AWS service that is called as Identity Access Management. So IAM is a very popular web services that are used that are provided by Amazon Web Service for managing different type of users, managing different type of permission, managing different type of service groups inside an organization. Especially those organizations which are having hierarchy. Hierarchy means based upon the you can say different roles, you will give different kind of access to that particular user. So in that case, identity access management is used, and the service is targeted at organization with multiple users or systems in the cloud, that the AWS products like Amazon EC2, Amazon Simple Database, Amazon Management Console is given to different users. So if you want to maintain such type of users with different roles, then identity access management is more uh, applicable, right? So directly I'll go to the demo part because we have very limited time. Okay, those who want, if you have a Amazon account, you can open it. So you can type Amazon Web Service. So you can create an account in Amazon Web Service. You will get free services for a period of 1 year. But every service is having some pre-quota. You have to ensure that you are not exceeding that particular quota. So when you want to create an account, you can click create account in Amazon EC2, and I can click sign into console. If I want to open the console, I can write sign in console because I have an existing account. Now you can see that this is AWS Management Console. Okay, I have logged into my system. That's why it is not asked me username and password. And while you log in into the system, it may ask you what kind of user you want to log in, because there is two user. One user is called as root user. Another user is called as IAM user. So you have to select root user, right? Now all the AWS based services that you can find here, like AWS service is based, those services are based on analytics, you can find here. If you want to go for blockchain based service, compute, container, database, machine learning based services, IoT based services, quantum computing based services, based upon that there are different type of services available in Amazon Web Service. So I am interested in the security related services. So I am selecting security, identity and compliance. So these are the different type of services that are available under AWS. You can explore any type of service, but the very popular service is called as IAM, that manage access to the AWS resources. Like in a company, like you have a startup company, you have, let's say, 5 people, and every 5 people should be given different role in your company. So you can go for identity access management based services. So I'm clicking identity access management. It will redirect to the IAM management console from AWS management console. So this is my IAM management console. You can see this is IAM. This is my dashboard. You can find a directory here at any point of time. If you want to move between the directory, you can move it. And this is more important. You can see in IAM dashboard, it is showing that you are a root user and you have a MFA. MFA stands for multi-factor authentication, which is enforced to the root user to improve the security for this particular account, AWS account. Account ID you can see here, right in the right corner. Let me quit this one so that you can see. Yes. And root user has no active access key. Initially, I have not created any access key, so I don't have any access key. And this is more important. When you are using different type of services, you have to see that what is the counter. That means it says that there is no user group created till now. There is no user here. Number of roles is 2. There is no policy and there is no identity provider. So I have not created any role here. So it is giving me 2 different by default role. And this by default role I cannot delete. Even if I select this one, click delete, it is not deleting, or it is not allowing me to delete this. So these are the by default roles are available. Okay, why I am showing this one? The reason is that once you done with identity access management, at the end you have to see that these values are 0. Okay, if you put a particular service and make it open, then if the user is using that particular service, you will be charged. Okay, and you can see the billing dashboard periodically when you use cloud based services. So this is my billing dashboard. If any amount is charged because of exceeding the free quota, you can find in the billing dashboard. And every month this billing dashboard is updated, right? So you can see month to date cost, last month cost for the same period, last month total cost, all these things you can find here. Okay, so let me go back to identity access management. So basically we are going to do 4 activities here in identity access management. The first activity that I want to do is to create user and adding them into group. So in the left panel, you can see there is user and there are different type of group. That is the first work we will do. Second work what we will do is that we will manage user account with passwords and policies. Every account can be assigned with a password and policy, and based on the password and policy, you can change different type of policies, or you can enforce the user to create the first create the password in their first login. Third activity we'll do is with respect to the group policy. Once you create user group, with respect to the group policy, these are policies. We'll edit some group policy. Fourth task we'll do is locating and using identity access management sign-in URL. If I'm creating multiple users, every user is assigned with some URL. Like here you can see, this is my account ID, okay, and this is my URL, sign-in URL for IAM user in this account. So if you use this particular link, so let me go for a incognito window and open this one. Okay, so through this, the identity access management users can access to my account. Okay, I am a root user. Under a root user, there are many identity access management users can be created. So all identity access management users can access this particular link to use my account. And I'll decide that what kind of services will be provided to which particular user. Okay, anyhow, it will come, right? Now, the first step which I mentioned you, that how to create a user. So you can create user, you can create group, you can create policy, you can go for account setting. All these options you can explore one by one. Now let me go to create a user. So I am clicking user. So it is asking in the right corner, you can see create user. Okay, let me sign in. Yeah, now you can see when you sign in, it is asking two user. One is root user and I am user. So I am writing my email ID. Okay, I am not a robot. I am clicking. Then it is asking me the password, and multi-factor authentication is on. So I am typing the password. So I am redirected to AWS console. Okay, again, yes, now it is available in IAM. So what I'll do, I'll create a user. So I can create a user with name, let's say user 0. Okay. Now it is asking, are you going to provide this user, okay, access to this AWS management console? Currently, I don't want to give. If you want to give, you can select this one. Then it is asking that I want to create a IAM user. For example, I want to create user 0 is a IAM user. And let's say the password. Either you can auto generate the password or you can give a custom password here. For example, I am giving the password fdp123 at, for example. This is the password. Okay. And if I click next, okay, it is shorter length. That's why it is, I think it is not taking. So I have created a particular user. Okay, I have created a user. Similarly, you can create as many as number of users, right, based upon your requirement. Now you can see this is my user 0, this is my console password, and this is the URL. This URL I have already opened here, right? This is my account ID. This is my account ID. You can see this number is matching with this one. Then I'm writing username is user 0, password is okay. So I am able to log in into my AWS account as a root user. And if I share my username password to my employee, then they can also access to my AWS management console. Okay, these are the two different accounts. But what kind of access I am giving to this particular user, that is more important. To continue, please verify your old and set a new password for user 0. Okay. So I have enforced some password policy. That's why it says me that change the password first. Okay, let me change it with some other password. So I have created a user and I have passed. Okay. So some confirm. I have confirmed my password. Okay, I have confirmed my password. Now, if it is accepted, then I will be able to log in using user 0. Okay, I'll show you here. Right. So I have created a user. Similarly, you can create as many as number of users as possible. Right. For example, you can see here now it will show only one user. If I go to user tab, then I'll create only one user. Suppose I want to create one more user with name user 1. Okay, I am simply creating another user. Okay, so you can see as many as users as possible you can create, and as it is a root user account, I am able to see that user 0 has logged into the system and 1 minute ago, right? But user 1 I have created now and nobody has logged in using user 1. So there is no last activity. But if I create, let's say a new tab, if I open, if I go for opening that account in another window with user 1, okay, you can see also in dashboard it is showing there are two different users. Okay, like that. Okay, here my internet is little bit slow, that's why it is taking a lot of time. Okay, so I am able to create multiple users into my account. Either I can give a auto generated password or I can give a custom password to each and every user, right? For example, if I go for user 1, now you can see here, this is the user 1. This is the login that you have to, this is the Amazon resource name of user 1, and if you want different permissions also you can add here. If you want any inline policy also you can create it, right? And if you need security credentials also you can create, like console password I have not enabled. Let me go for a custom password. If I write this is my custom password through which you can create the second user. Now this is my second user. If I write I am user is user, I think 2 or 1, you can see here there are two users we have created. The second user is user 1 or user 2, that I have to check. Yeah, user 1. So using this user 1 and password I will be able to log in another user. Okay, so once it is login, you can see the activity status is going to be changed here. If you refresh it, you will get the activity status. Okay. Yeah, now it is active. So this way you can add different users. Now you may create different user groups also. Why groups are created? Because with respect to group, if you want to enforce some kind of policies that you can enforce. Example, here I am creating one particular group. Let's say I am taking this user and I am creating a group, let's say group 0, because I want to give different privileges to group 0 people and different privileges to group 1 people. Okay, this is group 0 is having one user. I will give different permission and I will create another group. Let it be group 1 and I am selecting user 1 or user 0 both. I am giving different privilege. Okay, because in many organizations are having different level of employee. Every employee has certain restrictions, right? Every employee has having some restrictions, they cannot access all the things, right? So I have created two different group. Now once you create this group, suppose I want to give some privilege to group 0. Okay, so I'll go for group 0. I'll go to the permission. So in permission, you can see it is showing you can attach up to 10 managed policies. What is the managed policies? Like Amazon EC2 is also one type of service, Amazon S3 is another type of service, and there are different type of policies that are available in Amazon. What kind of policies I want to enforce to this particular group, that I need to mention here. Okay, suppose let me attach some policies. Yes, these are the some policies. For example, there is a policy called as Amazon EC2 full access. This is a policy. So I want to attach this one to group 0. Okay, so group 0 has provided policy of Amazon EC2. Now I'll go for another group. Let it be group 1. I am attaching some policy here. Let's say I am attaching a policy called as Amazon S3 related some policy. Okay, so I'm writing Amazon S3 full access. So those users are under group 1, like both users are under group 1, they can access Amazon S3, but the first user has only access to EC2. So if I go to the first user account, this is the first user account, right? Now this first user, if the user wants to access, let's say, suppose the first user access the Amazon S3 services, then you will get an error because first user has given only the permission to access Amazon EC2 resources, right? So if it tries to, you can see this is user 1. Actually, I am only using the in my same system. That's why it is some error is coming, right? But if you use the say, different system to access it, you can see there is no problem will come. Okay. So now if I go for any other service, for example, if I want to go for a blockchain based services, that is also not allowed because that type of privilege I have not given to this particular user. So what you can do, you can create different type of user, different type of group, different type of administrative policies, attach different type of policies using Amazon Identity Access Management. And if you want different type of password policies, that also you can change here. Okay, like whenever we are creating account, it enforces us to select some uppercase, lowercase number, alphanumeric character, or if you want some custom password, that also you can select. Based upon that, the user is going to create a particular password. Okay, so these are the different ways. In a overall way, if a company is having a hierarchical structure and you want to provide different type of cloud-based services, so you can provide these cloud-based services using Identity Access Management. Okay, so this is all from my side. So rest time we can discuss if you have any question. And once you use the service, kindly delete all these users and policies.
Participants, if you are having any queries, you can put up in chat box. I will convey the message. So, sir, I think there are no more queries.
Okay.
So, sir, on behalf of participants, I would like to thank you for giving such wonderful insights on cloud applications and showing use cases for using AWS and different kinds of access managements. So, thank you again, sir, for giving such insightful session.
Okay. Thank you. Thank you very much.
So, to the participants, we will be meeting again at 4 p.m.